In my previous videos, I've been talking about, first I've been talking about an observation we make in a room or a box. And I said this was events. And then I said that these events are waves in a field. And then I said that in this field you have points which has values which could give a raise to something that we may interpret as a wave or values that goes up and down. But I haven't explained how these values can arise in the first place, and I'm intending to do that now by introduce a concept of rotation and how rotation can be seen as being energy. And by saying that, I want to make a little, let's say, a little disclaimer here now. I'm not saying that this is how physicists approach these things. What I'm saying is that I'm going to show you a way how to think about it. And in doing so, I'm first going to show how rotation could be seen to be a wave, and then I'm going to show how a wave can be seen to be energy, and then I'm going to show how this connects back to the field. This is the outline of this video. So if you start with rotation, I want you to think about like a clock. So with a handle that rotates, we could call it a pointer or whatever, and this is, of course, since I'm old-fashioned, we're talking about an analog clock, which is going to be like a circle. Let's see if I can get this correct. Like this. And then we have a handle like this. This handle is going to rotate with a uniform speed. The direction doesn't really matter, but I'm just going to say it's going to rotate in this direction. And this is a fixed length of the handle. And if we think about these two axes here as a x-axis and a y-axis, so while the handle rotates, we could make a plot in this two-dimensional space. So that point there, the end point of the handle, is drawing this circle. So it's drawing a circle in space. And you can also think about it, instead of a handle, you can just think about it as a spot that rotates around here. But what we're going to do now for this presentation, we're going to think about it with a handle, and that handle has a length, okay, and then it's going to rotate like this. So this is a spatial representation of the rotation, but we can also represent this in time. So as the handle rotates, time goes by, and then we could show what I would call the time dependency of the position of this spot here. And we do this by drawing yet another diagram like this. And now we have time here. And again, I'm just going to call this a value. So here we have X position, and here we have Y position. And now we're going to translate this into a time dependency. And we're going to look at how the Y position change over time. So if, let's say, if we start here, I have to make a clarification first. In order to understand how this time dependence will look like, we can look at the segment of that circle like this. So here is the y-axis, and here comes the x-axis. If we look at this segment here, it's more or less like a line like this, a vertical line. And if we look at, extend it a little bit here, if we look at this segment here, it's more or less like a line like this. And if we look in an in-between segment, it's more or less a line like this. And this tells us a little bit about how this curve will look like, because when it now rotates, we're going to look in time here. So we're going to have time points, just let's say this is seconds. It doesn't matter what time unit it is, but we're just saying it's seconds. So this is 1 second, 2 seconds, 3 seconds, 4, 5, blah blah blah, etc. Now let's say from going to here takes 1 second. Then we want to know no, I think I'm going to say 2 seconds. 2 seconds, 6, 8. Yeah. I will start with 2 seconds. It makes it easier then. Let's say it takes 2 seconds to go here. So how will the y position change over time in the first, if we breaks up this in segment here? So if this is 2 seconds, this is 1 second, and this is ½ second. What in this region here, when the yeah, what I want to say is like if the handle is here, you can read off the y value here, okay? And the same thing, you could read off y values all the way here. So how fast does the y value change over here? Well, if we go back and look at this direction here, we see it goes straight up. That means in 1 unit of time, you will have a very rapid change upwards. That means it will look something like this in the time dependency. And when we come here to the midsection, we see it goes on the diagonal. It means it's like a little bit in between. So it takes 2 seconds. So this is 1 second. This should be in this here we have 1 second. So here we have a ½ second. So the first ½ second is very rapid move, but then after 1 second it will start to slow down a little bit like this. And then if you look at 2 seconds, the change is almost nothing. So it will flatten out on the top here. And then for this segment here, we will just have the same thing but opposite. So it will go up fast and then intermediate like this. Okay? And then we come here and it's just the same thing. But now notice this is plus here, and this is minus here, and this here, the values is 0 here. So when this pointer has moved over here, the y value is 0, and then it goes into the negative. It means it continues down into the negative area here. And then at 4 seconds, so this is, well, I made a mistake here because I was making it uniform. So it should actually go down here. But, well, we could just change the time and say it takes 3 seconds to go here. So that means that the peak should be about here. So then we will have something like this. And then if that's 9 seconds over here, 9 seconds over here, then we'll have something that goes like this. Now it looks very messy. Doesn't look beautiful. But I think you understand. What you're seeing here now, you see a wave. Okay? If we half the speed at which this rotate at, no, I'm not going into that because it's not relevant, because I'm going to have a uniform speed all the time here. What I want to say, if we make this handle twice the length, then it means that the maximum y value will be twice, and we will have a circle like this. And I think it should be quite obvious that this wave here now would be half the size. The time dependency of the position will be half the size. And if we double up this here, then we will have a wave that is double up like this. Okay, I hope this is understood. Now imagine we compress time here. So like this is not 9 or 10 seconds here, but this is 1 hour. That means if we, so when we draw this thing here, the wave peaks becomes very compact. Like this. So we don't see the individual waves anymore. What we see is just this like compact wave. Now, if for instance this here is a shorter handle that rotates here, then it looks like this. And this is over here we have time. If for some reason while this thing is rotating, the handle jumps up, the length of the handle goes up here and rotate. That will mean we have a doubling of the value here, and it will start to look something like this. Then maybe it jumps back down here again. Then it will looks like this. My point is the value can change. Okay? And this handle